Hi everyone, today I want to talk about some different options you have for architecting your Flutter app. This is in terms of things like file structure and folders, going from what I'd say is probably the worst approaches all the way to the best, but I don't think best is really the way to put it. As you'll see, there's definitely different patterns that work depending on what your project is, the size of your team, and so on and so forth. So let's get into it. All right, here's what I'd say is objectively the worst option. You have a main.dart file and you put everything in it, everything in one file. I've seen this before. Okay, some pros of that. You don't have to open up more than one file, just get your text editor open and just keep it there and don't close that file and just work in it and you're good, I guess. There's a pro. Con would be you have to get really used to your mouse wheel, if you have a mouse, because you're going to be scrolling a lot, and also get that Command F or Control F on Windows ready, because you're going to want to be searching around. You're going to want to it's going to be a bit of a nightmare. I mostly included this as a joke. Don't do this, but I will show you an example of what this might look like. All right, so here we have a main.dart. It's the only file. Oh, actually, no, we do have a test, which is good. We have a test that is just testing if true is equal to true. So, we have full test coverage. Again, a joke. Very good. But yeah, our main.dart, we have our run app, we have our stateful widget for our super awesome app with a whole bunch of, stateful properties and lovely functions to update that state. There's our actual main widget, a material app, everything is inside of it. That's okay, fine. So on and so forth. This is even that big. I just made this kind of as a quick joke. But yeah, we have some different widgets, tubular widget, funky widget. Put these in their own files, and ideally put them in folders that make sense, which we'll be getting into next. So that was worst. Next we're going to get into layered architecture, which is a lot better than the worst one. The idea here is that you're going to kind of separate sort of like a folder structure based on the different types of Dart files, really. So if I was going with this approach, like to kind of have everything broken into components. Those are basically widgets. You could call it widgets if you want. I love the word component. It just feels nice. Sure, it's a few more letters, but whatever. So that's where you'd have your UI components, and it could be lists, it could be detail things, cards, so on and so forth. Then you might have a models folder, and that's where your models would be, the things that store the data of your application, of each feature, we'll say. So you might have a post model, a user model, and many other models for each of your features. Then you might have a providers folder. This is, definitely true if you're using something like Provider or Riverpod. If you're using Block, a little bit different, but the concept still remains true. You can kind of have a folder that represents stuff to do with your state management in terms of, lists and detail and events and all that kind of stuff. So your providers folder, screens folder, you can also call this pages, whatever you want. I like screens. I feel like pages reminds me of making like a web page, and we're kind of, beyond that usually when we're working in Flutter, or we should be. You shouldn't be making a web page in Flutter. So we'd have one, a post screen, a user screen, all these kinds of things, many screens. And then services, and this is what talks to the outside world, whether it's an API or, some kind of, native thing or whatever, usually an API, at least in most apps I build. So these are, the Dart code that actually would go off and make an HTTP call and give you back a response, so on and so forth. So some pros of this. It is a pretty simple structure and it separates your concerns. And frankly, it's reasonable, I think, for a small project, especially something that doesn't have like a lot of functionality. If it's an app that kind of just does one thing and does it well, you might not necessarily have to break things up like we'll see in the next couple options. Some cons of this is you're going to have many files in each of these folders. So I was just kind of showing some examples here. Services would have this, this, and this. But if you had a lot of features, this one folder is going to become massive, and especially massive if you're using any kind of code generation too, because a lot of your files will have a .g.dart associated with it. Also, this isn't really portable, which will make sense, I think, in the next one a little bit more, what I mean by that. But essentially, if I wanted to pull this stuff to a new project, like a certain feature, like say I made this post feature, and posts being, like an Instagram post, a Twitter post, whatever you want to call it, an X post. if I wanted to pull that out, I would have to kind of cherry pick out certain files. Okay, I need the service, I need the list from here, I need the provider from here, maybe multiple providers, so on and so forth, and pull those out and reintegrate them into another project. So let's take a look at this. This is a real project, and it was one that I decided to follow this because it is pretty basic in terms of functionality. There's not, things like auth in it. There's not a lot of different models. It's a really, straightforward thing. For context, what this project looks like, this is a Flutter web app. Really meant for mobile, but works totally fine on desktop, and that's where I'm showing it, obviously. But it's kind of like one of those Spotify Wrapped sort of things for Beatport, which is a DJing music service that's been around for 20 years. We built this as kind of like a celebration of their 20-year birthday earlier this year. So on and so forth. It's pretty straightforward. I mean, there's a lot of cool animations, and it is playing sound, but I'm not gonna get that playing and get this demonetized. But essentially, there wasn't a lot of reason to break things up in what we'll kind of see in a future version. So really, the structure of it is there's a lib folder. You obviously have a lib folder in your Flutter project, and then we have your components, we have models, we have providers, screens. So they're just kind of like separated, just like I was showing in this example right here. So yeah, good use case for that on a simpler project in terms of like models and features. So that's layered architecture. Let's go to the next level up. Let's talk about feature-based architecture. This is generally my go-to. And what this means is we are going to have sort of in our lib folder, likely in our lib folder, maybe even a subfolder down in a folder called feature, we're going to have a subfolder for every single feature in our app. And to me, a feature, you can think of it, especially if it's an app that's connected to some kind of RESTful API, a data-driven sort of app. Each feature is kind of like a model or a database table a lot of the time. So you might have things like users, posts, comments, tags, likes, all these kinds of things. And what you want to do is actually have a folder for each of those. And then within each of those folders, we kind of follow the layered architecture view. So we have components, we have models, we have providers, and in each of those we have, the various components that go with it. So postcard component, post detail component, form, and so on and so forth. Models, we have our model. We might also be keeping something like our form state in there, which is, also a model in some sense. We have, various providers for our list, our detail, our form itself, and our service. Okay, cool. And then we have various screens, a root screen or like a list screen, detail screen, edit screen. These are just examples, but just trying to give some sort of real world context here. And then we might have a services folder with our post service, and that's the part that goes and talks to our API. So some pros of this is it will keep you really well organized. And this makes it really easy. And if you're a freelancer in Flutter and you want to recycle code that you've written between different projects, something, I do every day, this makes it a lot more portable, right? Because instead of cherry picking out those different files, I can pull this entire folder here into a new project and, probably have to make some adjustments based on the new project's requirements, but the general structure and functionality will be there. And just by copying one folder over. The only con I can think of this approach, and it'll make more sense in the next topic we'll cover, is if your backend essentially changes, like say you were using Firebase and you then wanted to go to maybe Superbase or like a RESTful API or ServerPod or something, it's a really big refactor because you kind of have that sort of logic of how the models look, really like mapping a lot to your API or whatever it is. And we want to change that. It's going to be a bunch of work. Now, that's fine if you're deciding to change, your backend service. It should be a lot of work in some ways. Like, you don't want to put so much effort and energy into in that off chance that you end up like taking way longer to build it. But it's just something to think about. If you're prototyping something and you want to really like make sure that it can be flexible in the future. It is one sort of con of doing this, and of course a con of any of the ones we've covered so far. Let's see an example of this. So firstly, one example you could see in further depth of this is my open mic series. We are building it with this approach in mind. It's not full on clean architecture that we'll get to next time, but it's kind of this, feature-based approach that I think works really well and is nice and organized. This is just a different project just to show something else. But yeah, we have our, inside our source folder, we have a feature folder. And these are all different features of this app. So for instance, if I opened up, let's look at genre. So, this would be like a genre in music. And we have within that feature components, models, providers, screens, and services. So, within components, we might have the card that basically represents, the genre with, the inkwell around it that you can tap on and the name of it and what the track count is. We might have a grid, right, which is kind of like the list of those things as a component. There might be some toggle switches to, turn on and off things, that kind of stuff. Within models, we actually have the, genre itself. In this case, we're using freezed. You could use whatever you want and still follow this pattern. But basically, this represents, how it lives kind of on the database side and works within our application. So, it's ID in the database, it's UUID in the database, what its name is, the category, and, et cetera, et cetera. So we have the models folder. Providers, so we might have a provider to get a list of our providers by talking to our service that we'll see in a minute. And then we might have a provider, in this case, a RiverPod provider that basically uses a family to retrieve based on a UUID and keep that in memory for future use. Then we have screens. So we have our, our list screen here, which is just, a screen with an app bar and, this screen. Actually, in this case, in this app, we don't actually have a screen that just lists the genres. So maybe a bad example, but obviously you can imagine we could have that grid shown here, that kind of thing. And then similar with the detail screen, we have our app bar and we have our, place that's putting, we would put the genre information or whatever. And then the service itself, is just dark code that goes and talks to our service using HTTP and lists and whatever. So that's kind of how I have it broken up to sort of paint this in a real world kind of way. So that's feature based. And lastly, let's just take a look at what is called clean architecture. Now, I have done a full series on clean architecture using Block. So if you're really interested in that, definitely check those out. But what's different about clean architecture? So there's some similarities with the feature-based. For instance, we still are going to have a a folder rather, for each feature. But instead of going right into models, components, et cetera, we actually have this broken into 3 layers: a data layer, a domain layer, and a presentation layer. So here's our data layer. Within that, we have data sources, which essentially is how we talk to the outside world in terms of a data source, whether that's a RESTful API or Firebase or whatever. We have mappers generally, and this is kind of like how do we convert the one that we're getting from our data source into code, into our local version of the code. So it just allows us to, essentially we're going to work with this, this is going to turn it into something and also turn it back. It's kind of like a to JSON from JSON kind of idea, a little bit different, and maybe an example it'll make more sense. And then we have the repository as well, which essentially works with the data source and is actually the implementation to make the calls and so on and so forth. So the data layer, domain layer works a lot with the data layer. But we can kind of think of this as a lot of it is like an abstraction of this. So think of a lot of the data stuff, you'll see here post data source implementation and post repository implementation. These are specific implementations based on the service we're going with or our backend type. Whereas these would become more abstract models, our post data source and our post repository. This is us we would build this first before actually the data layer and kind of define how we want it to be working in our application. Also within here is our version of the model that we'll be working with. So that could be freezed or something else. And then there is some providers. And this is actually how we, in our UI and other providers, how do we actually speak to our repository, which speaks to our data source. Cool. Hopefully that makes a bit of sense. I think an example in a moment will, hit it home a bit more. Then we have our presentation layer. So we can think of this as partly it's UI. And I like to have a screens folder. And I know I'm skipping ahead. We'll come back to that. Screens folder. We have a components folder, or you call it widgets. And this is basically where anything, UI visual sort of happens. However, I like to also put in my presentation layer any of my providers that are managing state, because to me, that is still part of presentation. It's, the state of the application from that the UI is going to map to. I know there's, some people do this a little bit differently and they have all their providers within the domain layer, but I feel like certain providers live more in domain, in my opinion, and some providers would live within the UI when it's really just things like presenting the state of a list or presenting, the detail of something, the state of a form, that kind of stuff. And then we have state, and this is obviously works well with those providers, but you might have a post form state. Is the form dirty? Is it empty? Has it been submitted? And then the data within it would be all stored within there. And then like post list state, what page are we on in this pagination? Is there more pages? What are the actual results? That kind of stuff. So that's kind of, look at it just as a reminder. Data layer, think of that as your implementation with your, external service. Domain layer is kind of like your design of your application's data, how you want to work with it, regardless of what the backend is. This is going to be agnostic. It's just like the way that you'll have it set up. And then the presentation is the UI and really just anything to do with the app itself outside of, fetching and responding to data. So that's that. Pros of it, again, this will keep you really well organized. It's, again, going to make the features portable between projects with little effort. So same as the last version, we can copy a full feature over and, aside from some changes, it'll basically, in theory, work in your next Flutter project. I find this is really great for large teams and enterprise projects, and really makes it work well with developer separation. So in a sense, say you had a couple devs working on a project and one was more I'm, maybe more of a junior and better with dealing with the UI sort of stuff, whereas you have a more senior person that wants to deal with more of the, the data layer and maybe even the domain layer. It allows those things to, be worked on, I think, a little more simultaneously. It allows you also, you could build your project, make the data layer a mock layer completely. Maybe the backend's not ready yet. You can essentially get a lot of your work done in your project by, doing that, and then swapping it out later with the real data. And if you did it properly, it should just keep working, which is cool. Another pro here, and probably the biggest pro, is if you wanted to change your backend. So maybe you launch on Firebase or Supabase or something, and you decide, I want to go to Django later. The idea is you really only have to change your data layer up here, because these are the implementations of these kinds of, of your domain layer and of your presentation layer. In a perfect world, you do it right. All I have to do is change these files essentially, and it should just work with your other service. Cons of this, it's a lot of boilerplate, a lot of files, a lot of duplication in some ways, because you're making abstract classes and inheriting them or whatever, and you're just doing a lot really to just future proof your project. And I think for a solo developer or something that you're not going to be changing your backend or working with other people on it, I would say don't go this approach. I think it's just a lot. You're going to spend a lot more time getting to market, building it this way. Sure, you'll be proud of it, but honestly, I think you'll be proud of getting to market even more. So in sort of summary of that, I do want to show sort of an example of how you could have this set up. All right, so I'm here in a project, and I'm just looking at the Flutter app part of things right now. I'm in lib, I'm in features, probably make this a little bit bigger. And let's just pick a feature like game, which, this is like a video game or whatever. And you'll see we have the data, domain, and presentation. So let's start with domain, because in architecting the application, I feel like this is probably the code you would want to write first. And essentially, we have the data sources. So game data source, let's look at this. What's interesting here is this is an abstract interface. We're not actually writing any code in here. We're just kind of designing the shape of our data source. So we know there's going to be 4 different endpoints we have to worry about integrating. There is a list endpoint, which is going to require a page, a limit, and maybe a optionally game system UID. That's so that you can get games just by a particular system. In this example, we're going to have a retrieve. It returns a game. We're going to have a save. It's going to return a game, and delete won't return anything, but requires the ID to be passed in. So we essentially are creating, that sort of pattern. This doesn't do anything. It's just an interface. Also in our domain layer, we're going to have our different models. So we might have our game model, using something like freezed, and this is essentially properties and methods and some factories and, just that kind of stuff. We're going to have providers. We're going to have a provider to talk to our data source, for instance. This one might look a little bit confusing because of some reasons I'll get into in a bit, but you can kind of just think of it in a way that we are just, sort of injecting in the different providers and getting access to it in our code using game data source provider. We can access anywhere. It's basically a singleton in Riverpod. And then we have a repository. And the repository is pretty similar to our data source. The main difference is we're using FP Dart to basically handle like errors and stuff like that. So that's kind of like the design of like, how is our integration going to work? Now on the data side, let's actually look at the data source implementation. So what's cool about this project is it's kind of an example that's kind of perfect for, what I'm talking about. I actually have 3 different data sources. So there's actually a data source for how would this project work if it was connected to Django? How would it work if it was connected to ServerPod, which is a Dart-based backend framework? And how would it work if it's connected to Supabase, which is a platform as a service? So the idea would be, let's look at the Supabase one. I feel like maybe Flutter devs would be more familiar with Supabase, but essentially what this does is it implements that game data source. This is what we saw at first, and we actually write the implementation of how this would work. So how does the list endpoint work? We have to follow the same pattern there, but we actually go and we use our client. This is actually just the Supabase client, as you can see here. Fetch from this table, select using whatever, and filter, and so on and so forth. So we actually write like the implementation for the list. We do the implementation, for the retrieve, and so on and so forth, saving, all that kind of stuff. And just to look really quickly, like how would that look in Django, or really, a RESTful API? It doesn't necessarily have to be Django, but the idea is we're actually using a REST client now and going and getting it and whatnot. They still are always returning the same kind of data to our domain layer. So that's kind of how that works. And then, in the data layer, we looked at domain, we looked a bit at data. I know there's a lot more into it than this. And then the presentation, we have our providers. So we have, a provider to manage our state of our form. We have providers for our paginated list, essentially, to load the data and so on and so forth. We have screens, we know what those are. We have state. So this is the game form state, and also the paginated list state, what different states we can have for that, and so on and so forth. And then widgets or components, like I have previously, which has things like our detail, our form, our infinite list, so on and so forth. So that's kind of, what I wanted to show there. Now, whether it be clean architecture or the previous version, I just wanted to quickly speak to, obviously your Flutter app is going to have more than just like, starting with a feature. It has to be kind of embedded. So generally how you would have this is you'd have within your lib folder, I like to have like a config file, or config folder rather. This is where you'd have things like constants, environment, maybe theme stuff, colors, that kind of thing. Then you'll generally have a core folder where you might break up in sort of like a feature-based architecture, shared components, models that aren't necessarily feature-specific, providers like maybe a REST API provider or whatnot. Basically things that aren't feature-specific. You might have your router in here. I see that as something that's pretty core. You might have theme stuff, and you might have sort of some shared services. Then next to core, we have the features folder. And then within there is basically our post, our user, and so on and so forth, which then becomes this. And then we'll have an app.dart and a main.dart usually. Main.dart being the thing that does the run, maybe does a few other setup things, and your app.dart is kind of like your main, app itself. That's how I like to structure it. And again, this applies, this right here applies to the clean architecture, but it also applies to feature-based. All right, I'm going to leave it there. What I want to do in the next video, which isn't, it's not like this is part of this series, but it's kind of like it's kind of like an additional video once you've watched this one that I look to put out. I want to give you a more in-depth look at this project, which is called Houston. Houston has been a long project for me. I've rebuilt it many times in different languages and so on and so forth. You might be familiar with it. In some of my previous videos, I've mentioned it and I've shown different states of it. But I've gotten it to a really cool spot. It still has more work to do, but the idea is a really nice clean architecture setup that will work with different code languages, different backends. All with code generation and a million things. Definitely out of the scope of right now, just want to get this video out, but stay tuned for that. I'm going to show you a bit about it, kind of demo it, and I am kind of at the point now where I'm looking for some help on it, some open source contributors. So definitely stay tuned for that if you think it's cool, and I'd love to see you. So say bye to Dash, and we'll see you guys in the next video. Thanks.